Hello and welcome back to Math Tutorials. Been a while since our last video, but today I'm going to be going over the Senior Maths Challenge 2022. Okay, we're going to be starting with when the expression, when this expression is simplified, which of the following is obtained? Oh, whoops. So this is a pretty simple one. All we have to do is we have to know the difference of two squares, so we get two, or you could just multiply them up, but it would be much easier if you use the difference of two squares. Um, like 2 minus 1 multiply by 2 add 1, 3 minus 1 times 3 add 1 times 4 minus 1 times 4 add 1, which is just going to simplify down to 5, and then we get 5 minus 1, which simplifies down to 4, then 5 add 1, which simplifies down to 6, all divided by 2 times 3 times 3 times by 4 times by 4 times by 5 times by 5 times by 6. So this cancels with this 5 cancels with this 5. This is just 3, so we can cancel this and we can cancel this. This is also 3, so we can cancel this, cancel this. This is 1, so it just doesn't matter. This is 2, so that cancels with that cancels. This is 4, that cancels with that cancels. This 4 cancels with this 4, and we end up with just this remaining 5, so we end up with 1 over 5, and we get D. Okay, now next question. No. Okay, with this one, you're going to want to be careful. What's the smallest prime, which is the sum of 5 different primes? So, let me just get snipping tool. Oh, whoops. Uh, so what you have to first notice is just cross out a new number that's not primes. This one you can pretty easily tell with a multiple of 3, 39. So cross out 39. 53, is that a multiple of anything? Not too sure. The rest, I think they all prime. So, but they're not too sure. But let's get into it. So, you just want to write down all the primes up until like 20, because if it's a 5 different primes, the primes are all going to be um less than the number, obviously, and you don't need to go too high because you can just tell. So 2, 3, 5, 7, 11, 13, 17, 19. So to get 41, is it possible to get 41? Because you want the smallest prime. So is it possible to get 41 from adding 5 digits here? So 19 add 3. Oh, or let's say 19 add 2 times 4. That is 27, I believe, but that is not prime. Okay, what about if we add 2, add 3, add 5, add 7, so that's 5, 10, 17, add 7, that's not 17, add 11, 28, okay, no, doesn't work. Is it possible to get 41? So we got 27, 28, if we get 13, it's possible to get if we get 13, add 17, that is equal to 30. Then we get 3 numbers, 1, 2, 3. Add 5, 3, that's right, 35, 38, 38. We can add 2, that gets to 40. Add 7, 38, 45, no, that gets to 45. Or if we add 11, that gets us to 49, that's not prime. Okay, let's try some other numbers. Sorry, it's just taken quite a while. Yeah, it's quite a difficult one for question 2, I would say. Maybe there is some shortcut techniques that I haven't seen yet, but I would say it's quite difficult for a question 2. Um, I mean, compared to some of the later questions at least. 5, 7, add 11. Okay, these two sum to 8, this sums to 15, this sums to 26. So we got 26. So what's 26? Add 17. That is, what's that? 33, 43. Is that 43? That's 43. There we go. Okay. Now I'm just going to assume it's 43 here. It could be 41 as well, but I do not believe it can be actually, because we sum like the smallest digits and we weren't able to get 41, but I believe it is C. Okay, question 3. This is pretty simple one. Actually, not really for question 3. But so we got a regular hexagon. We have to find out how many um parallelograms there are in the figure. This was even a kind of a tricky one for me to spot, but I just kind of couldn't see the rhombuses or the parallelograms the first time I saw it. Well, they are rhombuses as well, but I guess technically. But there is here. That's the parallelogram. And what you get is that you compare up this triangle with this triangle to make a rhombus there, if you can see it. And then you compare up this triangle with this triangle to get a rhombus, so you can kind of just keep on going. And what you notice is that you end up pairing. There's the number of ways to choose two adjacent equilateral triangles is 6, because it's just one for each line, pretty much one for each of these lines in the middle. There's one line there, 2 lines there, 3 lines here, 4 lines here, 5 lines here, 6 lines. So I believe this is C. Question 4. This is actually a pretty similar one to forgot when the years back, but pretty similar to this. Diagram shows 2 symmetrically placed squares with side length 2 and 5. What's the ratio of the area of the small square to the area of the shaded region? So if we want the ratio, so first of all, if we want the area of the shaded region, we notice that we have to get the area of the whole square, and then we have to half it. So let's just find out that. So that's just going to be 5 squared divided by 2 for that this whole triangle. If you count that if you shade that as well. And in order to get the area of this small triangle, you do 2 times 2 divided by 2, which is equal to 2. So shaded region, shaded, is equal to 5 squared over 2 minus 2, which is also equal to 21 over 2, I believe. Yeah. And then, so what's the ratio of the area of the small square? Just out of the shaded region. So area of the small square is equal to 2 squared, which is just 4. So we want the ratio of the area of the small square to that of the shaded region, which is 4 to 21. So we 21 over 2, so we end up with 8 over 8 to 21. We end up with D. Okay, so so now we've got just addition with fractions and whatnot. But so what you can do here is you can just try and add up kind of ones with similar bases. So just kind of forget about the 1. We'll leave because that's just that's a 1. We can see that's a 1. But so let's think of this and this. So we can times the one on the left by 10. So the base becomes 11, so we get 10 over 11, add 1 over 11, which will end up as 11 over 11. And similarly, we can times the one on the far left by 100 to get 100 over 1.01, add 1 over 101, which is equal to 101 over 101, which is equal to 1. This is equal to 1 as well. We sum this, we get 2, then add the remaining 1, and we get 3, which is C. Okay. What's the value of this large power? Quite similar to last year again. So what we just want to do is we know we kind of just want to see the highest common factor of both 800 and 400, which is 400. So we get 4 to the 2 over 8, the power of 400, is equal to this fraction. Let me just double check that. Yep. So that's equal to 16 over 8 to the 400, which is equal to 2 to the 400. And that is option E. Oh, what is happening? Snipping tool. There we go. In 2021, first class stamp cost. So we've got a stamp that costs 85p. Well, we've got two items. One costs 85. One costs 66. In order to spend an exact number of pounds to buy at least one of each type, what's the smallest total number of stamps that should be purchased? Okay, so we want some multiple of 85. Home. Add some multiple of 66. 66p is equal to some multiple of 100, because 100p is for £1. We want at least one of each. So that means we know we're at least going to get 166. And what we notice here is that 85 is actually 90 minus 5. And 66 is actually 70 minus 4. So what we want is for like kind of like minus 5k minus 4p to this. We definitely want this to be a whole number, or like a multiple of 10, including 0. And the only way for that to happen is for this, the minus 4p, to be a multiple of 10 itself, regardless of the minus 5k. So we at least need 5 lots of the 66p. So let's start with if we have 5 lots of the 66p. So we get 5 times 66, which is equal to 330. And then from this we can kind of just see that so we at least need one lot of 85 as well. So 330 adds 85, because we need at least one of each envelope, is equal to 415, I believe. And we can kind of just see now that we need one more 85 to add, and then we get a whole number. Then we get 500. So then we got that's adding another one stamp, adding to this 85. This 85 means another stamp, and then the 330 means 5 stamps, which is equal to 7. That is C. Quite a lot of C's here. In the diagram, the outer hexagon has an area of 216. What is the shaded area? Okay, so what we can first do is kind of just split up the outer hexagon into equilateral, or at least what's it called, isosceles triangles at least. But we know that all these triangles are congruent, and we end up getting 6 triangles. So let's call the area of one triangle T. So we know that 6T is equal to 216, which implies that the area that T is equal to 216 divided by 6, which is 10, 25, 36. And one thing you always want to recognize with just regular shapes is that you know the angles. So for this hexagon, obviously to get an interior angle, you can do what's that? Was it 100 or n minus 2 times 180? I believe for it, and then divided by n, I guess, for interior angles. But what I like to do, because it's just easier to calculate, is find the exterior angle and minus that from 180. So I do 360 over n, which is 6 in this case, n being the number of sides of the shape, and then I minus it from 180 because that's just much easier to calculate, because look, then we get 60, and we do 180 minus 60, and we get 120. So we know each of these angles here are 120, and because we know these triangles are going to be congruent, each triangle is therefore going to have a what's called side length of it's going to be equilateral. It's going to be at 60 degrees, so this is going to be an equilateral triangle because this is going to be 60 as well. So this is going to be 60 up here. So so we know it's an equilateral triangle. So we know, so we can work out the side length by just doing half AB sine C being being sine 60 in this case, AB just being side length. So if we call this x, this is x as well. So just half sine 60x squared being equal to the area of one triangle, which is 36, which implies that sine 60x squared is equal to 72. So x squared is equal to 72 over sine 60. Sine 60 is root 3 over 2, so 72 divided by root 3 over 2, that's 72 over root 3 times by 2, which is equal to 144 root 3 over 2. No, this would be root 3, yeah. Over root 3. Okay. So x is just the root of that, yeah. So now what we want to do is, we've got the side length of the outer hexagon. And what we can notice here is that we actually have like another triangle here, just there. So we can kind of extrapolate that, I guess you could call it. And so this is going to be x, this is going to be side length x, no, it's going to be 120, and we know it's going to be an isosceles triangle, so we know these bits are going to be 30. And what we can also notice is that there's also, or actually we don't even need to look at the whole triangle, or this triangle that I've just mentioned, but we do need a side length. That's a very important thing to work out. So we've got an equilateral triangle here. You can kind of, yeah. So we've got an equilateral triangle here. If it pretty much with math challenge as well, if it looks like something, it most likely is. You don't want to exactly assume that, but you can with this one you can tell, because in a hexagon or like in any shape, when you're making something, things are very when you're like adding in lines inside that shape, things are very symmetrical in terms of like, well, with regular hexagons of course, but things are just very symmetrical. Like if you so if you cut the shape in half, for example, you already know that the angle is the angle on each end of the line is going to be half of each other, which is going to be 60. But back to the main point, you can see a large equilateral triangle, right? And that base there is going to equal, so we actually do need the triangle from before. X split down half, get that, we get 60 here. The base is going to be the adjacent here, so adjacent is cos 30 times x. So the base of the equilateral triangle, or the large equilateral triangle, is cos 30x, and what we want is or 2, because you need, because a is just one side, so you need to times it by 2 for both sides, here. So the area of the whole triangle using half AB sine C is going to be half. It's actually going to be a. This is a squared half AB sine 60. Now we want to minus the area of these smaller equilateral triangles. Area of smaller equilateral triangles is going to be sorry. Area of the smaller. What have I done? Solved it just a couple of days ago, but no, it's yeah. So you see, it's equilateral, so it's going to be equal to this x. Yeah, it's going to be equal to x. Yeah, it's going to be equal to x, but I'm thinking. Oh, I've kind of confused myself here, but the more, I think I'll come back to this question later, but maybe I think I messed up with my variables because I called too many things same variable, but you basically want to get the area of these equilateral triangles and minus it from half a squared sine 60, and then yeah, then you get your answer. Sorry guys, I know this is a bit a bit dodgy, but yeah. Okay, next question. Um, a light nanosecond is the distance that a photon can travel at the speed of light in 1 billionth of a second. The speed of light is 3 times 10 to the 8 meters per second. Okay, so we want to use our simple equation. V equals this is displacement, velocity. No, sorry. Displacement equals velocity times time, or distance equals speed times time. For you physicians, this is looking weird, isn't it? Having S is speed, but so we know speed equals 3 times 10 to the 8 in 1 billionth of a second. So that's actually a nanosecond. We can kind of just tell, because 1 millionth is 10 to 6, and a billionth is 10 to 9. So it's 1 billionth, so 1 over 10 to the 9, which is just 10 to the minus 9. You can say 1 times 10 to the minus 9, doesn't really matter. So the distance is equal to 3 times 10 to the 8 times 10 to the minus 9, which we end up with 3 times 10 to the minus 1 meters. So converting that to centimeters, we times by 100. 3, and we end up with 30 centimeters. Distance B. Okay, now next question is pretty simple. It's just a equation. Oh, it was quite refreshing for question 10. It's like that. So obviously multiply both sides by the denominator, which is 3 add 2x at x squared, and we get an equation that looks like this. This 3x squareds cancel out. Then we get 1 minus 8, or 1 minus 9, sorry, is equal to 6x minus 2x, and from this we can kind of just imply that x is minus 2, because, 4x is minus a, obviously. Don't want to go through all the steps, because you guys are smart, I know that. And here, what you actually want to do though, just to check. Actually, you don't need to check really. No, never mind. It's the. Oh, interesting one. Senior Math Challenge really loves the number 2022. It's oh yeah, it's year 2022 as well. Interesting, but yeah, just remember 2022 is equal to 2 times 3 times 337, which is 7. Um, okay, so in the number triangle shown, each disk is to be filled with a positive integer. Each disk in the middle or top row contains a number which is the product of the two numbers immediately below it. So what's the value of n? Okay, so we get this. Let's call this A. Let's call this B. So this must be NB. This must be AN. Hence 2022 is equal to AN times NB, which is equal to ABN squared. And what you notice here is that, so you know 2020, so you know 2022 only has 3 factors, or 4 technically, if because you have counting the 1. It's AB times N squared, and what you can notice here is that since these are all integers, of course, the only way for there to be a for there to be a square number is if the square number is 1, because there's no other way to get a square number from the left hand side, like because there's no other factor of 2, there's no other factor of 3, there's no other like each prime number or each prime factor appears 1 time, hence that n must equal, hence n must equal 1. Which is A. Okay. What's the sum of the? I'm gonna skip this one, but here it's just a little thought experiment for you guys. Just you like if you're doing this, you probably already know it, like in terms of this trick, but just call n 1 2 this 6 the 6 rays, and then what you get is just n squared, or or call it the free phrase, the free the free the free the free number actually. Then what you get is just 2n. You can already kind of spot the difference of 2 squares. But this just makes it easier for calculations. In terms of like writing out, you don't have to write out all the 6's at the same. You don't have to write out all the 6's and all the 3's and whatnot. So yeah, you just end up with 3n squared, and then given that in this diff, you can. That's just a hint, like what's it called? A kick boost, I guess you could call it. Okay. Quite fun, isn't it? Um, 3 rugs have a combined area of 90 meters squared. They're laid down, completely covered with a floor of 60 meters squared. The area which is covered by exactly 2 layers of rug is 12 meters. So I'd C is equal to 90, right? The area of this is the area of rug 1, area of rug 2, area of rug 3 equal to 90. So the area, so that should be equal to 90. So given that they completely cover a floor of 60 meter squares, there is 30 meters squared excess, you could call it, or like that's covered by, yeah, excess. So given that, so if area is covered by 2 rugs is 12 meter squares, that means in that 60, once we cover in the 60 meter squares, once we cover it all, we then kind of add another 12 meters squared rug up on top of it. So we know where some of the excess goes. We know there's 12 meters squared excess. So we know there's now 19 meters squared excess for the 3 rugs. Which must mean that the area covered by 3 rugs is 9. Since once you get that, because the excess, because once you get 9, once you cover, like once you first cover 9 meters squared, for example, in order to get 18 meters squared excess, you must cover a further you must keep on covering that 9 meters squared with the other 2 rugs, and then you end up getting 18 meters squared excess. So the answer should be C. Okay. Diagram shows square. Blah, blah, blah. Basically, in the ratio 1 to 2. So this is the ratio 1 to 2, and this is ratio 1 to 2. Okay, 1 to 2. 3 sounds like a good number to split this up. So you can kind of you just put a number out there. Just put a nice number that's like nice. Do calculations with, or like nice to divide with. So we get 1 equal 1 to 2 ratio. This is 2. So the 1 squared or 2 squared, root of that, that's root 5. Splitting the 1 to 2 ratio, so this is 2/3 of root 5, this is 1/3 of root 5, which is root 5 over 3. This bit is root 5 over 3, extrapolating that, we get this hypotenuse, or the length of the smaller square, to root 5 over 3, just be 2 over 3 root 5 squared, which is 4 times 5 over 9, that's 5 over 9, using Pythagoras, which is 25. 9, the root of all that, because Pythagoras, is equal to 5 over 3. A fraction of the area of KLMN is shaded. So the area of the smallest square is just going to be 5 over 3 squared, which is 25 over 9. So we don't even need to root it. And then so we just put 25 over 9 over the area of the largest square, which is 9. Well, KLMN, which is just 3 squared. Yeah. And we end up with 25 over 81, which is A. Yeah. Going pretty smooth. Very smooth. Okay. Hair on the tortoise. Come on. So the hare and the tortoise both had a race over 100 meters. 100 meters. This is length for 100. In which both maintained constant speed. When the hare reached the finish line, it was 75 meters in front of the tortoise. So when the hare is at 100 meters, it's 75 in front of the tortoise, so hence the tortoise is at 25 meters. The hare immediately turned around, and so this also means in the time that the hare runs 100 meters, the tortoise runs 25 meters. So the ratio of the hare speed to the tortoise's speed is equal to, it's in the ratio of 4 to 1, since 4 to 1. Since every 4 meters traveled by the hare, the tortoise travels 1. The hare then turned around, and hare turned around. How far to the finish line? From the finish line, the hare and the tortoise meet. So we want to divide 75 into 5 parts, so we can get in the ratio of 4 to 1, and we get 25. To get that in the ratio of 4 to 1, we get in the ratio of 20 to 5. So 25. Yeah, and then kind of, so it's the same as just the ratio 70 to 15. So the tortoise travels 15 meters from here, ends up at 40. Hare travels 60, and they end up 60 meters away from the finish line, which is B. Okay. Which diagram to be a sketch of the curve? Okay, so let's rearrange for y. Y equals 1 minus root x all squared, which is equal to 1, add x minus 2 root x. Now for those lower years, you might not know this, but higher years, it's just the trick that you want to use. Just differentiate here, and we get 1 minus 2 times a half x to the minus 2 minus a half, which is 1 minus 1 over root x. So we see when x is really small, the gradient, like this number, when x is really small, this number kind of goes to infinity, so you get negative infinity, so the gradient is really small, or like really negative, at, as x goes near 0. So it can't be e, first of all, because e is part of the constant gradient. Not going to be d, because d is like, d has a stationary point, or d has, the d gradient is 0. Can't be C because similar reason to D. B, and it can't be A, obviously, because it doesn't have a negative gradient. But so it is B. Okay. Whew, let me just get a sip of water. Whew. The shape shown is made by removing 4 equilateral triangles with side length 1 from a rectangular hexagon with side length 1. So there's the whole shape. You can use what's the area of this shape? Okay. So we can just split this up into 8 triangles. We know it's 1, 2, and we know this length is going to be 1 using the area. So if we connect this here, then we know that x. Let's find out the interior angle for octagon. 360 over 8, which is equal to 10, 20, 30, 40, 45. So we do 180 minus 45, and we get 135, I believe. This is all in degrees, yeah. So we split. This angle here is 45, but we can also look at this angle in the center here. This angle in the center over here, which is because it's going to be divided into 8 triangles. If the angle up there is going to be 45. And so what we end up with is an isosceles triangle. Bottom length 1, this length 45, this length 135 over 2. Okay, let's split this up again. And let's take this over here. Get a right angle triangle. 45 over 2. 135 over 2. Right angle, you know, it's going to be 0.5. So I know the height, let's call this h. This height is the opposite, so it's equal to if we're talking in terms of angles, adjacent is going to be 0.5 over tan 45 by 2. Now what we want to do here is use the double angle formulae for tan theta, which I believe is give me 1 second, guys. Oh, yeah, but that's why it's very important. Like, 'cause once you get into year 13, or like just higher years, I'm not too sure what's called in other places, but just the high level math techniques that you get, the double angle formulae, differentiation, the chain rule, just different mathematics techniques, especially when you radians can be very useful when dealing with geometry problems, especially with circles. So So double angle formula, I believe it for tan. This is for tan. It is taking me quite a while, isn't it, guys? Um, ah, okay, there we go. So tan 2x is equal to 2 tan x over 1 minus tan squared x. Well, doesn't have much here, does it? So we can rearrange maybe. So we get 2 tan 45 over 2 over 1. No, there is another way. So we can let's just approximate this. So you know tan 45 is 1, because when you think about the angles, it's just split in half. It's just this perpendicular angle split in half. You get 45. So when you get 45 over 2, you can kind of just half that again, but you can't exactly because um, obviously the rate of change of side length with angles isn't constant. There's a different rate of change, but let's just approximate that to be 0.25. So let's approximate h to be 2 because this is 0.5 and 0.25. That's 2. And then the area of this, so then this would be root 5. The area of this would be. Let's actually come back to. I'm gonna be honest. I would go a similar method to this, but what I would do is I would use sine instead of tan. But yeah, just let me know in the comments how you guys would solve this. Let's skip that one. Uh, numbers, blah blah blah. But okay, so this is simple equation. Sorry. I've got my way to solve it. I'm just thinking of another way to solve it. Because I think a method a way just came into my head. But I'll ponder on that. 3 to the y. 3 root 3 minus 3 to the x add 1. 3 to the x add 3. So my handwriting's a bit dodgy on this. Okay. Let's turn on something neater. 3 to the x add 3 to the 2, just down the half, so that's 2.5, minus 3 to the x add 2, 5 root 3. We can factorize out 3 to the x, and then we get 1 minus 3 to the 2 is equal to 5 root 3 minus 3 to the 2.5. So we get 3 to the x is equal to 5 root 3 minus 3 to the 2.5 over 1 minus 3 squared is minus 8. Did I go wrong somewhere? But anyways, 3 to the y is equal to 3 root 3 minus, oh, we can tell it to add 3 over 8 lots of 5 root 3 minus 3, 2.5. So 3 to the x, so 3 to the y. Just add those equations together now. Quite inconvenient to rub out. 3 to the x or 3 to the y. We do that here. We get minus 5 over 8 root 3 add 3 to the 5 over 2 over 8 add 3 root 3 add 3 over 8 or 15 over 8 root 3 minus 3 to the 7 over 2 over 8. So we get 10 over 8 root 3 so forgetting, and then we get add 3 to 5 over 2 minus 3 to 7 over 2, so that's just, let's just still quite the top bit of the fraction. 3 to root 3 add 3 to the 5 times by root 3. What's 3 to the 5? 3 to the 4 is 81 times by 3, that's 243. Then either root 3 minus 3 to 7. Okay, what's actually going to be easier here is just to factor it out. 3 to the 5, so 3 to the 5 times by 3 to, that's times by root 3 minus 9 root 3. Let's check that's right. Root 3, you get 3 to the 5 minus 3 to the 7, factor that out. 3 to the 5 minus 3 to the 7, 3 to the minus 2, 3, yep, should be right. That's equal to 3 to the 5 times by minus 8 root 3 at 10. Okay, guys, I do not know where I went wrong, but I went wrong somewhere. But when you calculate, use this method, but I think my algebra was wrong somewhere or something. When you calculate, you should get 2 root 3 as the answer. Sorry. Getting a little woozy, a bit tired maybe. Don't know. Oh, okay. How many pairs of real numbers x, y satisfy the simultaneous equation? Okay, so what you can see is that the x's and y's are swapped around in both equations. So first of all, notice there's going to be an inverse function. So for the first graph, we have y is equal to 2000. Oh, so y is equal to x squared minus 2022. So this is a graph of y equals x squared shifted down by 2022. So we get something like this. Since that, and then with the second equation, since we know this is going to be an inverse function, it's actually in the line y equals x. It's going to be something like this. So we know there's one solution here, no solution here, no solution here, no solution here. So this should be 4 solutions. But since I should pair the solutions, this solution here, we know when someone is reflecting the graph y equals x, the y and x coordinate just swap around. So it's still going to be the same pair. Hence, there's going to be 3 pairs of solutions. So it should be D. I think I'll stop with the next one. I'll stop at question 20. But yeah, just because by the time you're watching this, there should be other videos out, maybe even solutions will be out, so you can just you can use those as well for the later questions. So square of blah blah blah. Circle has radius 10. Okay, if this is kind of, remember what I said before about with geometry problems and just shapes, a lot of things are symmetrical. So so this is symmetrical in terms of like this angle here is equal to this angle here, and then this line here is the bisector of the shape. So what you can kind of deduce from that is that this angle here is equal to this angle here. Oh. So you can tell these are this is the same. So what you'd have is these angles being 45. These angles being 45, and the base. Let's call the length of the square 2x. So we have this being base 2x. So we split this in half, and we get this small bit being x. So the height is also x, because it's just tan 45, which is 1 times by x, so just x. So what we can now do is we can extrapolate the shape. Oh, this is a really bad drawing. Oh, it knifed itself up. So what we can do is we can use the fact that the radius is 10. We have to kind of point it here. We know this length, so we can use Pythagoras here. So we know this length here is going to be 2x over x, so that's going to be x. We know this length here is going to be x. We know this length here is going to be 2x. So what we get is that 3x all squared add x squared is equal to 10 squared, which is equal to 100. And what we want is for the area of the square is 4x squared, because we want 2x all squared, which is 4x squared. So we get 10x squared is equal to 100, which implies that x squared is equal to 10, which then implies that 4x squared is equal to 40, which is D. Oh, thanks for watching. Hope you guys enjoyed the SMC. Yeah, well, catch you guys in the next video.